All right. Good morning, everybody. So, yeah, today is going to be the first video of a new series, which is about deploying Node.js to serverless environments. And not only deploying, because you kind of have to change the architecture a little bit, but yeah, not too much. Yeah, more specifically, we're going to be deploying to AWS using Lambda functions, and then also the surrounding services that are required. But yeah, more on that later. This video is a first introductory video. So we're gonna have like a top level view of what we're gonna be building, a little bit of a theory, and then starting with the next video, we're actually gonna write code and deploy the sample application and build out the deployment process and so on. So in the end, the goal is to have one code base which can be deployed to a development server and also to the production server. I'm going to use GitHub Actions for the deployments. So no manual deployments. I'm also going to link a custom domain, well, 2 custom domains for 2 servers. And I think that's it. You're gonna see on the way what else we're gonna do. Yeah, and we're gonna make a nice and smooth setup. So for this video, I just wanted to go over the different types of architectures and how serverless compares to them. And then we're gonna go over to the next one and start coding. So let's have a look at monolithic architecture. This is how most of the servers used to be, and still up to today, a lot of servers are that way. And me personally, I tend to sometimes use this kind of architecture because it's really quick to get going. You just have one server, and you can deploy that to I don't know, to Heroku or render.com. Made a video about that for each of those. You can get started really quickly, but there's also some limitations. I mean, the first one would be that you have to manage your infrastructure, and let's say you want to build a global service, a global server, then you have to deploy that to different regions, right? So with render.com and Heroku, I think they only have 2 regions each. So you can choose, okay, do I want to host it in North America or in Europe? And then once you want to have something in Asia, you have to choose a different one, right? Maybe they have regions there, but yeah, it's kind of a pain a little bit to have that in a different part of the world. And then what else is there? Yeah, so once you have everything in one server, well, it gets kind of hard to maintain, right? Because you have one code base. Although you might argue that with any of the architectures, you want to have everything in one code base, but still, probably this server is going to be too interconnected because it's trying to do everything. And then if you change something in one place, it might break the other part, right? And the same goes for performance issues. So if you have a performance issue with, let's say you have a server that has functionality to modify images or something like that, or large files, then this is gonna use up a lot of resources. And at the same time, if you're handling API requests with that server, they're gonna be in conflict, right? So you're never gonna have a super smooth performing API server, and then well, unless you don't have any load on it. But and in addition to having some kind of file modification or whatever, so there as well, if one part of your app is a little bit more resource heavy, you have to scale up more quickly and so on. And then also your server's running at the whole time. You don't you can shut it down, but then it takes a lot of time to spin it up again. So yeah, overall not the best. But plus is that you do have a pretty quick start. So to get around that, people started setting up something called Microservice Architecture, where you had basically a couple of different smaller servers. they might be running in the same environment, sort of, but definitely different processes. And maybe you would have them separate, like in separate code bases. But yeah, so there, the problem about having the connected, well, one large code base or one large process that does everything, obviously it's a bit better because, yeah, let's say one server goes down or one service goes down, then the other one is still there, right? It's not going to be affected. So that's good. The problem with that is that you have to manage all of those, right? And this can be a pain as well. So not the best solution either. Well, a pretty good solution, but yeah, you kind of get gets a little bit complicated at some point. Okay, and you have the same problem with the international deployments, and they're even worse because you have to spin up 3 servers, let's say, in 2 or 3 different parts of the world. Then yeah, you end up with 6, 9, whatever servers that you have to manage. Not only 1 or not only 3 in the case of international deployments. Okay. Yeah. Then finally, we're gonna go to serverless. And this is with AWS. So the serverless is not unique to AWS. I personally like AWS quite a bit, so I'm using that. But you could also use Google Cloud or whatever. So how that works is that there is a middle layer that handles all the incoming traffic and then redirects it to the correct function. Now this part is kind of, well, you kind of have that with the other architectures as well. You don't necessarily see it, but you probably have it as well, or your hosting provider does it for you. But yeah, the difference here is that your server is not running like the whole time. It's not running 24/7. So if you don't have any requests, you're not paying anything. And what you do is you provide the code, and that's it. And then the code is being run by AWS or Google Cloud or whatever. Yeah, in my case, AWS. And that way, nothing can break. Well, obviously something can break, but nothing regarding the infrastructure can break by having an error in the code or something like that, right? If that function execution fails, it's okay, it's gonna fail, and then it's gonna shut down right away, and then the next function invocation is not gonna be affected by that. Whereas with these services or one monolithic server, if those fail, then your server might hang and just shut down completely or something like that. You don't have that problem here with serverless environments. This takes a little bit of time to get started, I would say. At least took for me. Once it's set up, it's really smooth, so no problem with that. And then also you don't need to worry about auto scaling. You don't need to worry about international deployments. Or different regions, because usually the hosting provider does all of that for you. And it makes sense because, I mean, AWS or Google Cloud, they're doing that. Well, it's the main thing what they're doing. So why not let them do it for you and simply just provide the code that should be executed, and then let them handle the rest, instead of having sometimes just one person or multiple people just being responsible to make sure that the servers are running smoothly and so on. So yeah, this is definitely a nice setup, and I wanted to get into that for quite a bit. Always push it off a little bit. Now I finally did it, and I actually kind of like it, and I think that's gonna be my go-to solution moving forward. My go-to architecture moving forward. Okay, something specific to AWS and how we're gonna build it is there's a couple of services that we're gonna use. The first one is CloudFormation, which basically is just the declaration of your architecture, right? This is their servers. You send them a JSON file or YML file, and then they know, okay, we're gonna spin up this function and this other service and so on. So this is quite handy. And then also, well, one part that is spun up with that is a service called API Gateway. This takes in all the traffic from all the clients and then forwards it to the correct function. And then the function executes something, returns something, and that goes back to the client through the API gateway. You can plug in more services, something like S3 or whatever you want there. If you're using some of the AI services that AWS offers, basically anything that AWS offers, you can connect into the Lambda function. But you could also do that before with any of those architectures. So it's probably a little bit easier here because you already, there's already the permissions. I think they're already there. But yeah, more on that later. So overall, I think that is a really sweet setup. Now here you can have, multiple functions for different events. You can have whatever you want, basically. You can have any kind of trigger. Our trigger here is for this series are gonna be HTTP requests. But it might be something else. So in the docs they say, for example, if an image is being uploaded or a file is being uploaded to S3, then you might have a function execute based on that event. As I said, we're just gonna worry about HTTP requests for now. Okay, well, I think that is it as far as the introduction goes. Hopefully you got a little bit of an understanding on how this works. If not, don't worry about it. We're gonna get hands-on with actually writing code and deploying and so on, running with the next video. Yeah, let me know if you have any comments, and otherwise, see you in the next one.